And now we'll be talking about the cofunction identities. The cofunction identities state that the value of any trigonometric function at x is equal to the value of the cofunction at pi over 2 minus x. So here we have two examples of a cofunction identity. One is sine pi over 2 minus a as an angle, is equal to cosine a. And cosine pi over 2 minus a is equal to sine a. Here we can make the statement that sine is the cofunction of cosine and cosine is the cofunction of sine. So make sure to remember this relationship. Now we'll be proving the cofunction identities that we just stated. So first is an algebraic proof. Recall from Sam's video that the angle subtraction formula of sine is sine alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. If we apply sine pi over 2 minus a into that equation, we obtain sine pi over 2 cosine a minus cosine pi over 2 sine a, and that is equal to cosine a. Therefore, we can state that sine pi over 2 minus a is equal to cosine a. The second is a geometric proof. So here we have a right angle triangle with other angles theta and phi. We can make the statement that phi is equal to 90 minus theta. And we can also state that sine theta, since it's opposite over hypotenuse, is equal to b over c. And cosine phi, which is adjacent over hypotenuse, is also equal to b over c. So we have the relationship that sine theta is equal to cosine phi. If we substitute 90 minus theta into phi, as we have stated here, we get sine theta is equal to cosine 90 minus theta. And that in radians is sine theta equals cosine pi over 2 minus theta, which is, in fact, our cofunction identity. Now finally, we are going to prove this graphically. Because cosine x is a even function, we can say that cosine x is equal to cosine negative x. And below we have the graphs of sine x, which is the red curve, and cosine x, which is the blue curve. So remember this relationship that cosine x is equal to cosine negative x. If we shift the cosine x graph given below to the right pi over 2 units, we can write that as cosine negative x plus pi over 2, because we stated that cosine x is equal to cosine negative x. And if we rearrange this, we obtain cosine pi over 2 minus x. And now what is that? If we see in the graph below, if we shift this graph pi over 2 to the units to the right, we see that it is identical to the sine x graph, because as we see, the two are pi over 2 units apart from one another. Therefore, we can say that according to the graphical proof, if we shift cosine x to the right pi over 2 units, we obtain sine of x, which is our cofunction identity. Now here we have some examples. Prove that tangent pi over 2 minus a angle is equal to cotangent a. Tangent pi over 2 minus a can be rewritten in the form sine pi over 2 minus a over cosine pi over 2 minus a. Now because we know our cofunction identities, we can rewrite this as cosine a over sine a, and that is equal to cotangent a. So we have just proven that tangent pi over 2 minus a is equal to cotangent a. Here we have some more, that leads us to more cofunction identities that we sort of have to keep in mind. So here we have tangent pi over 2 minus a is equal to cotangent a, and from that we can also say that cotangent pi over 2 minus a is equal to tangent a. And the other one is secant pi over 2 minus a is equal to cosecant a, and vice versa, cosecant pi over 2 minus a is equal to secant a. So we can all prove this using what we have used to prove in the example previously. And notice that these cofunction identities come in pairs, that secant and cosecant have a cofunction relation, and that tangent and cotangent have a cofunction relation. So it's very important to memorize the 6, so including cosine and sine, these 6 cofunction identities to solve examples in the future. Another example. If tangent pi over 3 minus a is equal to cotangent pi over 3, what is a? Given that a is an angle between 0 and pi over 2. So we can say that tangent pi over 3 minus a is equal to tangent pi over 2 minus pi over 6 minus a. So why am I putting this in this complicated form? That's because I want to put it in a cofunction format, which is tangent pi over 2 minus some angle. And that some angle here is pi over 6 plus a, because we can take out the negative sign. And this is very important because this allows us to utilize the cofunction identities. Here we can say that that angle, which is pi over 6 plus a, is cotangent pi over 6 plus a, because we know that tangent pi over 2 minus some angle a is equal to cotangent of that angle a. Now cotangent pi over 6 plus a, as given in the problem, is equal to cotangent pi over 3, because we have the condition that tangent pi over 3 minus a is equal to cotangent pi over 3. And this leads to the answer a equals pi over 6, because pi over 6 plus a is equal to pi over 3. Another example is cosecant 17 pi over 6. So finding the exact value of this given formula. Cosecant 17 pi over 6 is equal to 1 over sine 17 pi over 6. And again, as we have done in the previous problem, we are writing this in a new sort of cofunction format, as I would call it, in order to utilize our cofunction identities. In this case, it can be rewritten as 1 over sine pi over 2 minus, parentheses, negative sine pi over 3. Now, because sine and cosine are in cofunction relationships, we can rewrite this as 1 over cosine negative 7 pi over 3. And because cosine is an even function and cosine negative x is equal to cosine x, it can be rewritten as 1 over cosine 7 pi over 3. Because we know that in the unit circle, angles 2 pi apart have the same values, it can be rewritten as 1 over cosine pi over 3, and that is equal to 2. So we can see how this complicated problem has simplified into a value that we know, which is cosine pi over 3, and that's 1 over 2, because we have utilized and transformed this equation in the cofunction format. And then the cofunction identities allow us to come from sine to cosine, and that leads us to our final answer. So finally, we'll be reviewing the formulas that Sam and I have touched upon. So here are some key formulas of this angle addition and subtraction formulas for sine and cosine. Make sure to remember this, and based on the mnemonic device that Sam had provided you with. So S, again, is, you remain in the same sign, so stay, and C is change, which means you have to change the sign. Another formula review for my part on the cofunction identities, and the one thing I would stress is that they always come in pairs. So sine, cosine, tangent, cotangent, secant, cosecant.